Okay, so we're going to transform random variables by adding or multiplying constants and see how that impacts our mean, our standard deviation. Basically, we're going to look to see how it impacts measures of center versus measure of spread because it impacts them differently. So consider the following scenario. On the last test, there were the following grades. Okay, so I'm going to input that data into the calculator, and I took a moment and input it all into I went to stat edit, and I entered all that data into L1. Okay, and then real quickly, I just went stat calc one variable statistics. I don't have, and so I press second one. I don't have any frequency, so I can just clear that out. So that should be blank. And I get a mean of 79.5. I get a standard deviation of 21.86. I'm going to assume that that's the entire population. So I'm going to use the population standard deviation. Okay. If I scroll down, I can find my minimum value is 28 and my maximum value is 100. So my range of scores was 72. I have a median of 85.5. The variance just came from squaring this equals 21.86 squared. Then my IQR happens to be 92 minus 75.5. So Q3 minus the Q1, just like we've done before. Okay, so as your teacher, I decided to add 5 points to each grade. Recalculates the statistics. So first off, just thinking about this, if I add 5 points to everybody's grade, what's going to happen to the average? Well, it's going to go up to 84.5. And not surprisingly, the median will change by the same amount. So let's go ahead and look at this. And this is a typo. This would be 90.50. So stat calc, or excuse me, stat edit. I'm going to go up to top column of L2. I'm going to press second one. I'm just going to add 5 to it, plus 5. And it added all those values. I'm going to go stat calc, one variable statistic. My list that I'm interested now in is an L2, so second 2. And sure enough, the mean went from 79.5 to 84.5. The median went from 85.5 to 90.5. What happened to the standard deviation? It didn't change. And neither did the range. And when we look at, and then while our Q3 and Q1 changed, 97 minus 80 is still 0.5, is still 16.5. The IQR didn't change. Why? Well, it makes sense that this would change. So these changing by 5, that makes sense. But let's think about just talking about range. Let's just say the highest score on the test was a 100. The lowest score was a 0. Well, that would mean the range of scores is 100. Well, if I add 5 points, then it becomes 105, and this one becomes a 5, and the range is still 100. So here's your rules. The measures of spread are not affected by the addition of a constant. Really critical to know that. The measures of spread are not impacted by the addition of a constant. However, the measures of center are changed by the value of a constant. And the same is true for subtraction. So measures of spread are not affected by the addition of a constant. The measures of center are changed by the adding of a constant. Well, okay, so that takes care of addition and subtraction. What happens to multiplying and dividing? So let's go back and we're going to multiply every test score by constant and see what happens, all right, to our center and spread. So I'm going to go back to stat edit. I'm going to the top of column L3. And I'm going to say, let's take column 1 and let's multiply that by everybody's favorite number, 1.29. All right, so now I have a 129. So let's go stat calc one variable statistics. My data is L3. And I find out that I now have an average of 102.55. That makes me wonder, what would have happened if I took the 79.5 and multiplied it by 1.29? So let's do that real quickly. And it ends up getting 1.102.55. So I can multiply my mean, or I can multiply measures of center by a constant, and it works fine. So multiplying centers by measures of constant work fine. Let's take a look at our original standard deviation. Our original standard deviation was 21.86. And multiply that by 1.29. And it turns out that works as well. So it seems to work, and it works well for standard deviation, it works well for range, and it works well for IQR. But when I look at variance, it doesn't work. My variance was 477.86. Let's multiply that by 1.29. That's not nearly enough. Let's multiply by 1.29 again and see what happens. Oh, we get it. Why? Because variance is squared, we have to multiply it by the constant squared. So our original was 477.86. So I need to multiply it by 1.29 squared. So be really, really careful about this. When we're adding constants, we can add them to measures of spread and they'll change by the constant. When you add it, it does not impact, excuse me, I said that wrong. When we're adding constants, we can add it to the measure of center and they will change by that constant. In other words, mean and median will change by that constant. However, if you add it to measures of spread, they will not change. So adding a constant to measure of spread does not impact it. Don't do it. When we go to multiply, everything multiplies by the constant just nice and easily, except for variance. It has to be by the constant squared. So mean gets multiplied by the constant, standard deviation gets multiplied by the constant, the range gets multiplied by a constant, the median gets multiplied by the constant, the IQR does as well, but the variance gets measured by the constant squared. Please make sure that you get that, all right? The variance gets measured by the constant squared, all right? And if we just take the simple value of a range, if our original score was a 100, our lowest score is 0, we multiply by 129. This goes up to 129, and this stays at 0. And so certainly enough, our range is 129 and went up by the constant, multiplying the constant, okay? All right, so this concludes transforming random variables. Real quickly, one last time. You can add a constant to measures of center, mean and median. Easy to do. Do not add constants to measures of spread. When it comes to multiplying by a constant, you can multiply measures of spread and measures of center by the constant, with the exception of variance, which has to be the constant squared. Okay, thank you.